Hi everyone, welcome to my Java 8 series. In this video, we are going to discuss about functional programming paradigm. In our earlier video, we discussed in detail about what functional programming is and how we can simulate the functional programming with Java 8. Conceptually, we learned a lot, but practically we haven't seen any demos yet, but that will be done in the upcoming videos. In this video also, we are going to discuss the abstract nature of functional programming paradigm. Now, what is functional programming paradigm is? Paradigm is nothing but a pattern. So while you're applying a pattern in a functional programming, you need to follow certain rules or a constraint in which the constraints will be enforced in order to define the code as a functional programming code. What are those constraints? Number one, it should be a pure function. When you say functional programming, then it should follow the pure function standard. What it means by pure function standard? You have a functional expression here which is f of x equals x plus 1. Now if I give an input for the x variable as 5, then the output is predicted that it's going to generate 6 as an output. So always the output is going to be same. When I give 7, the output will be of addition, which is 7 plus 1, 8. But if you get 6 for the input of 7, then the operation is minus there. 7 minus 1, which generates 6. So that your function is producing different output for different input. Then that means it's not a part of a pure function. What pure function defines is, for a given functional expression, the argument value should not change its state. That's what we also discussed in the earlier video. So the first understanding here is it should always produce the same output. The function expression should always produce the same output, and it should not modify its argument, or it should not modify its variable, a global variable value, or even it should not produce some random output. Always the output should be of similar output, because the value of the variable should not be changed. This defines a pure function. So when I categorize a code as a functional programming code, the first thing that should be kept in the agenda is pure function, whether this code falls under the pure function constraint or not. And the pure function summarizes that it should always produce the same output, no random output, no different output, and it should not permit to change or modify the argument or a global variable. The next constraint for functional programming is recursion. Usually we used to apply a iteration via for loop or while loop in our programming code. Even in Java we used to do that, right? But when it comes to functional programming standard of code, you should not use for loop or while loop in order to do its iteration. Rather, you are supposed to use a recursion in it. Means you should call the function by itself so that you apply a recursion there in order to iterate the code. So iteration in functional language is implemented via recursion but not through for loop or while loop. How far this can be applicable in a Java programming language? It's hardly to implement, right? Yes, indeed. That's why I said Java 8 will not follow all the standards of functional programming, but it try to apply the major features of functional programming. Because all programming language can't follow the complete standards of functional programming nature. The next important constraint is referential transparency. It's more similar to what we discussed in the point number 1. You do not have assignment statements inside your functional expression. So if you see f of x equals x plus 1, that's it. There's no assignment inside the expression. X equals 10, x equals 9. So we don't do any assignment of value to that variable x rather than giving the input from the outside environment like 5. Once 5 is given, that's it. X cannot be changed. So you don't have the privilege to change the value of the variable. As simple as that. So an example is x equals 5 or y equals 10 or z equals 20, which you cannot do. You are not entitled to assign a value to a variable. So generally it means you don't have the privilege to assign a variable in a functional programming statements. No assignment of statements permissible in functional programming. That means referential transparency. Now, the next important term is functions are first class and can be higher order also. So meaning is one function, it should be purely function in a functional programming, and one function can take an argument of another function, and the function can return another function as a return type. A function can take an argument as a function, or a function can return the type of a function. Meaning is it's a first class function. Another statement is higher order function. What it means, higher order function is a function which takes the function as an argument and returns a function as an argument. Both are done in the same function itself. Then it is considered to be a higher order function. Then it contributes to the functional programming. So when a functional programming has a first class function standard, like a function takes a function as an argument, or a function returns a function as a return type, or a function which takes both, which does both the execution, like taking an input as a function and returning an output as a function, then it is considered as a higher order function. So a functional programming can be a first class function or a higher order function. And more interestingly, variables have to be immutable. I think this we have discussed much in detail. You don't have the option to change the variable. If in case you change the variable's actual memory is not changing its value. Instead, it creates another memory to store that value, changed value. So variables are immutable. Like for example, in Java, string is an immutable object. So if you try to change the value of the variable, obviously you're not trying to change the value of the variable. Instead, you are trying to create a new memory and then store the new value. So variables have to be immutable because the constraint says in the functional programming, the given value cannot be altered or modified at any given scenario. This is very strongly punched in the functional programming, but this cannot be followed completely throughout in Java's functional programming standard of code, because we try to follow that and apply that by using a constant term, okay, that we will discuss much in detail in the code, programmatic code. You will understand how we can deliver a immutability of approach in Java 8's functional standard of code by using constant approach. Now, so there are multiple standards of constraints that have been set, which is what we have discussed so far. So let's try to summarize it once again. The first one is all about the pure function. The second one is a functional programming should not allow for and while loop in it. Rather, you can use a recursion, calling a function by itself. Referential transparency have to be seen. So you are not entitled to assign statements, no assignment statements in the functional expression. And either a first class or higher order functions are contributing for the functional programming, and variables are immutable in nature. This satisfies the functional programming code. Now let's discuss about disadvantages. What are the disadvantages in functional programming? Sometimes pure functions will impact in readability of code, okay, because you don't have any assignment operations in it. You're not going to modify the variable value. So there are straightforward approach of code. So sometimes it's slightly more readable for its algorithmic implementation. So this is one disadvantage. Another disadvantage is, since you don't encourage the functional programming to support a for loop or a while loop in it, it seems to be a little intimidating for the code to understand or to execute the code. It seems to be a little complicated because you are going to approach via recursive nature of iteration rather than using for loop and while loop. That in turn impacts your functional programming under the category of disadvantages. So that's number 2. Number 3, when you try to combine your functional programming with other standard of code in your application, or if you are going to integrate your functional programming code with IO operations, you will face some challenges, a difficulty task. Because of synchronizations or parallelism in IO operations, you might deal with a little complexity when you are approaching with functional programming there. So integration with the existing application code and having a separate functional programming code in your application will be with a lot of complexities. You have to integrate them. So that stands as a disadvantage. Number four is immutability, and recursion will lead to a decrease in performance. The reason why I'm saying decrease in performance, it's because immutable values will keep generating a new memories. So unwantedly, we are investing cost on the memory, and as well as recursion, we don't know what might happen in the recursion, how it's going to be stopped. If there are random constraints have been applied in the recursion, then obviously it will lead to a performance issue. Since we don't have an appropriate control of iteration via while or for loop, recursion will lead to a dangerous situations of ending your application with. So immutability and recursion will also contribute the functional programming for its disadvantages. Now coming to the applications of functional programming, it is used in the mathematical computations. Okay, if your application is more of a mathematical computations, like for example big data, if you want to apply some filter or map in the big data of expressions, then sure you can go for functional programming. And it is also needed in the areas like concurrency or parallelism of code. So there you can see the functional programming is getting introduced for the concurrency and parallelism to speed up your process of code. But sometimes that also stays as a disadvantage, but we need to tweak around our application code in such a way that it doesn't ends up with any dangerous execution of code. We need to play safely with concurrency and parallelism when it comes to. So these are the applications of functional programming today. Now coming to the programming languages that supports functional programming are Haskell, JavaScript, Scala. These are the languages which supports functional programming in it. We do have the modern programming languages like Java, Python, C# have started to accept the functional programming standards, but 100% functional programming features cannot be implemented because of different other reasons, as we designed Java as object-oriented programming in mind, but not as a functional programming in mind. But it's good to support certain standards of functional programming features in order to ease up the developer's job in developing a Java-based application. So these are the different languages being highlighted here which supports the functional programming. Few languages are older languages which is not in use today, but few languages are still in existence who supports functional programming in it. A few facts about functional programming. WhatsApp application, which needs only 50 engineers to work around with the WhatsApp application, but still it has 900 million users, and it's highly supported because it uses Erlang. Erlang language is actually supporting the concurrency needs, and functional programming is applied over there. So Facebook uses Haskell in it and in its anti-spam system, and effectively if you look at the Haskell is supporting the functional programming. So these are modern real-time application which uses the functional programming in it via the languages like Haskell and Erlang. I just wanted to quickly give you about the fact is that practically are we using functional programming today? Yes, indeed we are doing it. And moreover, that's what we are going to apply when it comes to Java 8 functional programming or Java 8's Lambda programming. There we are going to follow certain standards of functional programming more in detail, but we might not have the full support of functional programming there, but at least we will follow certain features keenly in Java 8 Lambda expressions. In the next video, we are going to discuss about anonymous class, where we are going to start the practice of coding in Java 8, and the prerequisite for learning Lambda expression is anonymous class. Thank you.